Before the afternoon coffee break, we've got one more, and the topic is fibre ropes used in cranes, particularly tower cranes. We've started to see them on mobile cranes, and they're very interesting potentially for use on tower cranes. To tell us more about that, please welcome Marco Guariglia, who's Managing Director of Sales at Liebherr Tower Cranes. Marco's been with Liebherr since 2004. He entered the tower crane industry in 2011 when he joined Liebherr's tower crane business as a regional sales director. He's been global sales director since 2014. Please welcome Marco to the stage.
Thank you, Alex. You can hear me? Yeah, tough for me after such a very interesting discussion and virtual discussion about future benefits of systems like anti-collision and similar issues to say a fiber rope is something innovative. But anyway, I'll do my best. Maybe I start like this. Mike said this morning he's 35 years married. Christian said he's 53 years in the business. I'm not 35 years married, I'm not 53 years in the business, but I'll do my very best to reach that. Shortly, I have to say one more sentence to the topic before. I'm also sure that it will take probably forever or many years until we have an automatic crane system or automatic crane driving system. But I'm also sure that we have no chance to tell our customers the way they have to operate. So if I come back to the question about the concrete truck mixer, and I come from a Liebherr perspective, and we are producing also batching plant and truck mixers, I'm 100% convinced that in 5 years' time at the latest, the crane driver will see whether the truck mixer is on a delay or whether he's too early, and if he can make another lift or he shouldn't do it. So these are also the discussions we have from an OEM point of view, and that's by a fact, and for sure, I'm convinced it will come. So, how can we make lifting better? We have 5 companies, production companies worldwide. We have many sales and service companies worldwide. And we are almost every day thinking, how can we make lifting better? And why are we doing this? First of all, we want to make life easier for you. And we want to make your business hopefully profitable. That's one reason. It's obviously not the only one. The second reason is we want to make our life easier, and we want also to be profitable. And that's why we are thinking every day how we could do it better. The history of the ropes. I mean, you said it before, Alex, the fiber rope is nothing very brand new. There were a lot of tests in the last few years with fiber ropes and mobile cranes. There are many years now of discussion about fiber ropes, and so it's not totally new. So how is it coming to the fiber rope? Since ever, people tried to bring material from bottom to top and vice versa. Then, centuries ago, luckily, the hemp ropes were invented, and still today the hemp rope is in big use. This means, unluckily, there are still underdeveloped countries where time doesn't play any role, labor is cheap, the buildings are small, and safety is not such an issue as it is, for example, in this country. And that's why the hemp rope somehow is still in use. But the steel rope, obviously, is the rope, the material which we are using in our daily business, and luckily we can work with this. By the way, my timing is not running. Somebody has to give me a signal if I'm speaking too long. I want to speak about the fiber rope. Does it mean we will not need the steel rope anymore? Definitely not. So we are sure the steel rope will be used, I don't know if it's forever. Maybe if the automatic crane driver will come, maybe the steel rope will not be needed anymore. But bringing the fiber rope into our business, it doesn't mean that we will not need the steel rope. How does the fiber rope look like, and how did we came to the point to develop a fiber rope? So first of all, we started in 2009 to say, look, how can we give an added value to our customers? So we made some workshops, we had some discussions. We want to reduce somehow the load, however we can do it. And one issue was it could be via the rope, because if the rope is lighter, we can lift more. So speaking about the rope, not having the whole competence in our house, we said, let's look after a partner. In that moment, 2011, we started with Teufelberger to continue our discussion and to bring this item forward, let's say. What have we done since 2011? We consumed around about 70,000 meters of fiber ropes, which is equivalent to 55,000 hours of tests. We made these tests in a climate of 90 degrees Celsius. This means, for example, from -15 to +75, to have at least as close as possible tests to the normal environment where our cranes are usually working. 90 degrees Celsius, in your language, 153 degrees Fahrenheit. We created some tech labs. We created climate chambers. We brought out our stuff, let's say, where we used these fiber ropes. We tested the fiber ropes in sand areas. We tested where there is dust, obviously where there is rain. So we tried, in a theoretical way, to be as close as possible to the practical daily business in tower cranes. But still, we were on the theoretical side. I mean, in this country, obviously, there is no secret doing this. We had to make a whole lot of documents, and we are still doing it. And it's clear with such a new development, there is no way without clear documents. This is another example how we continued our testing. So the first was some chambers, some different climate. The second was, let's say, a stand with towers which is equal to a tower crane. Means we have done all the bends, all the rolls, so we could simulate like 5 to 6 crane types with the ropes, and that was the way how we tried to bring loads up and down with our ropes. One was in Spain. The second one, which you see here, is in Germany. And this is where we have done nothing else than bringing up the load, putting down the load, bringing up the load, putting down the load. You can compare it to a drawer test of IKEA. What are they doing? Close the drawer, open it, close the drawer, open it, until the day comes when you cannot close it anymore, or you cannot open anymore, or even worse, it's just damaged. And we have done nothing else. Up to the moment until the rope or the drawer was broken. That was our target at that moment. We didn't want to achieve anything else, so we know exactly when the time comes. And that's the result. The rope is called So Light. I'm not a big marketing guy, but So Light is standing for So Light. You could even say So Liebherr and Teufelberger, whatever. Anyway, it's called So Light, and that's the most important thing. It has the same row behavior like a steel rope. It has the equal diameter like a steel rope. And the added values are, it has by far more durable on site. I come to that later back on. It's free of corrosion, as there is no steel inside. This makes sense. And it's by far easier to handle it on site, especially for our guys who have to make the erection, our fitters who have to work with it. And ... What does it mean? 2009, we just had the idea to reduce the weight of our rope. Probably we discussed about better handling, no corrosion or whatever, but a lot of issues are coming up, and probably this is coming back to the discussion of these 5 people before. A lot of issues are coming up when you are doing something new. And I'm sure until we really will be in the market with this rope, there will be some more added values which we don't even know today. Our target was reduce weight of the rope. And this is what we achieved. We reduced the weight of the rope by 80%, or you can also say a rope which is more durable, corrosion-free, and better to handle has only 20% of the weight which a steel rope has. Coming from the theory, more to the practical side. I mean, you have seen all these fancy things, all these towers where we tested different possibilities, but it's still the theoretical side. Obviously, we had to say now we have to go on site and we really have to test it on tower cranes. So what have we done? We have chosen 2 to 3 models. We have put them in 5 different countries. We have used 10 cranes until now through over the last 1.5 years, and we were working really on site. I must admit we have chosen sites which were not longer than 6 months to be able get the crane back, get the feedback, test another customer, test another crane driver. So to be as close as possible, and even then we are not still there, to a daily business operation. To go a little bit more into detail, the 5 topics are safety, handling, lifetime, intelligence, and load performance. These are the added value of this fiber rope compared to the steel rope. Means a fiber rope is by far more safer than a steel rope. No, definitely not. There is no difference in the safetiness from the one rope to the other. But the added value is, today we still are struggling with the steel rope very often, that whoever is making the maintenance or the checkings of the ropes, it's by far more difficult than tomorrow with a fiber rope. So it's very easy to realize when is the time to change the rope. Ideally, touching it, but even from the cabin of the tower crane, you can realize whether you should change the rope, or at least you are so close to change it, now you should really touch it. Okay, so that's the point where we see an added value on a safety point of view. The handling. The handling in general is the same, but it's also clear, apart from any rope, for everything in life it's true, what weighs less is easier to handle. And this is valid also for the rope. So first of all, our guys on site are faster. It's an easier life for them. And as you need no grease, it's also cleaner. Just speaking about the rope, they wouldn't even need the gloves. But as we are erecting tower cranes, I guess it makes sense that they are wearing gloves. Probably the last picture is a typical emotion from an operator who is saying, look, this is another device where I'm happy to work with. Lifetime. With all our tests we have made, we are sure that the lifetime of a fiber rope is 4 times longer than a steel rope. In general, what does it mean? Let's say in general we say a steel rope lifetime is around about 2 years. 2 years, I mean, if you work in 2 shifts, if you have this operator, if you have that operator, it's difficult to say how long does it really last, but more or less we say 2 years. And if we say 2 years for a steel rope, we are 100% sure that with a fiber rope it will last 8 years. So this means this guy on the right side, 61 years old, he has one of these cranes. He will not see the day before he goes to pension when this rope will be damaged. I must say, if we are going up to 50, 60 degrees, the lifetime reduces by half. So we are saying in these emissions or in these temperatures, we guess we are around about at double to 3 times lifetime, to be very open up front. Intelligence. Is a steel rope not as intelligent as a fiber rope? No, it's the same. This is a matter which we want to promote in the near future with BOMA. So what we have done, I told you we had all these bendings and rolls in the tower sections, so where we could look into it and simulate different tower cranes. And in the future we have a system where we can always see how many rolls and bendings does our crane have and how often does the rope pass it, okay? So with this system, calculating backwards, we are saying we can calculate in the future always through algorithms forwards. This means in theory, sitting at your desk, looking into your computer, having this algorithm, in theory you can say, oh, in half a year we should look into it, it looks like the rope gets broken. Obviously, you still have to be on site, you have the responsibility on site, so it's 2 things. The desk is the theoretical thing, still the site is the practical one. But to run a company with 20, 50 or more than 100 cranes, this will help you to look after your spares, you look after your accessoires, and at the end to look after your ropes. And we will not have it as Liebherr at the moment for steel ropes. That's why I'm seeing added value, especially honestly for Liebherr at that moment. Load performance, I showed that before. So as the rope is part of the crane and it's by far lighter, there is more load performance. To give you an example with Liebherr Tower Cranes, if I take a 250-meter-ton crane, our hook today has a weight of 500 kilogram and our rope of 200 kilogram. Tomorrow, we will reduce the weight by 400 kilos, and this means 18% less. And this is added value. The crane is almost becoming one class bigger, and that's where we see a big issue for the future. To give you a second example, a 600 meter ton crane, the hook has a weight of 1,650 kilogram, the rope around about 500-600 kilogram. Tomorrow we will reduce this by 1,500 kilogram. And this is for us something where we say this brings us added loads on site, and we see a big advantage out about this. So these are the 5 points which we didn't know in 2009, but we hope to get some of them in 2009, where I can say this is the way we're going forward. We have made the theoretical tests, we have made the practical tests, and on BOMA 2019 we will sell the first cranes with this system. It will be not all of our ranges, but we will have 3 to 4 crane tribes between 200 and 300 meter tons, where we will sell with fiber ropes, and we will deliver them by the end of 2019. With the good news, I have to give you also bad news. The good news is what I told you until now. The bad news is I'm standing here in US, and obviously your heights are a little bit different than in Europe. Until now, it's working up to 100 meter. Means to give you an added value, we have to go higher. And there we are working on it. And I'm sure that until BOMA, we will have new information about this, because we are absolutely clear if we go to US and we say we have a perfect fiber rope, everything is nice, longer lifetime, less handling, more safety, but you say, gentlemen, we have to reach 150, 200, 300 meters, so your added value is no added value for us here. So we are working on this, and we will achieve that. At the end, I have your film from our marketing. I'm not sure if the guys made it just for general marketing. Probably they were also not sure that I bring the arguments on the table, so they made a film to ensure that my English, if my English is not good enough, they can show you by film what I was saying until now. So I give you the chance to watch into that.
The demands of the construction industry on modern tower cranes are growing steadily. Buildings are getting larger and larger and towering further and further into the sky. This requires innovations which go beyond the development of the structural steelwork for tower cranes. One pioneering answer to these challenges is the high-tensile fiber rope Solite, developed by Liebherr and Teufelberger. Solite combines the time-tested features of the steel rope with a much lower dead weight, thus opening completely new opportunities for readying cranes for the future. A wide range of rope prototypes have been tested to date on specially equipped test stands. Liebherr engineers from a number of different divisions have been working together to conduct series of tests on 70,000 meters of rope over a period of 55,000 hours. More than 8 years of joint development have been invested in the fiber rope. We actually bring the ropes to snapping point in laboratory conditions, which is why we know the limits of our rope very well. Solite consists of 2 components, the visible cover and the woven core inside it. The core is the load-bearing part of the rope, and the cover is actually only an indicator of when the rope needs replacing. The cover on the rope is made of fibers which wear at different speeds. This enables users to identify when the rope needs replacing safely and easily. In real conditions, crane drivers and experienced erection engineers work with the rope and bring their practical experience into the development of Solite on tower cranes. The big difference between the fiber rope and the steel rope is its handling, and of course its weight. The high tensile fibers used in the rope make it extremely lightweight. Up to 80% lower weight with the same lifting capacity that revolutionizes the assembly process. You actually don't need much strength to pull the rope over the rope pulleys. The rope also shows its positive features in other handling tasks. For example, there is no need to lubricate the rope, and that is not just something that can be seen. It also enhances safety on the crane. This crane is now 2 years old, and there are no signs of grease or oil anywhere on it. The fiber rope winds onto the rope drum just as neatly as a steel rope. Solite involves absolutely no compromises in this respect. Furthermore, Solite delivers a longer service life. The fiber rope can remain in use for up to 4 times as long on tower cranes. That increases the availability and profitability of the crane on site. I have had a fiber rope in use for around 2 years. We have not had any customer complaints, nor any problems about the rope being worn. The combination of the low dead weight of Solite and a potential weight saving of around 50% on the hook block means that tower cranes can now be used for a whole range of applications. This weight saving converts directly into higher lifting capacity, thus essentially increasing the crane's performance. Solite, an innovative development to satisfy the rising demands on building sites around the world.
So, thank you for your attention. This was it about our fiber rope.
Thanks, Marco. I wonder if there might be some questions. One down the back here.
Yeah, that's a great presentation. I have a question. I saw the fitting at the end. A lot of times, tower cranes, obviously there might be some damage near the fitting, possibly. How was that fitting going to be able to be put back onto the rope? What's the end point of installing?
I mean, you mean if the rope is breaking?
Yes.
I mean, if the rope is breaking, it's similar to a steel rope at the end, to be very honest. I mean, it's obviously easier to shorten it, which makes only sense to a certain height, because one day the rope is too short and then it's good for nothing anymore. But from a breaking point of view, even if you take, for example, a building, you have exactly the same issues like with a steel rope. So it's lasting longer if you have no heavy cuts, but at the end, if you cut it, you cut it. That's clear.
Okay, thank you. Another question?
Can you use the wedge socket?
Sorry?
Can you use a wedge socket with that rope? Can you use a wedge socket with a rope?
Can you use a wedge?
A becket, a wedge socket, a different termination end.
Yes, you can. Yeah.
You can, eh?
You can. Yeah.
Thank you.
Another question here?
I was curious, have you looked into maybe using them as trolley ropes?
Not until now. Yeah.
Just another one.
Comment in regard wire rope versus fiber rope in a power line contact situation, or how it would behave? Would it pop instantly or melt?
In all honesty, this question I cannot answer. So this would be something I would have to go back. I cannot tell you whether we have, for example, tested this until now. Yeah.
I'm thinking maybe it's non-conductive, whereas wire rope can electrocute the rigger, fiber rope might insulate the rigger.
I mean, there might pros and cons. I mean, on the one hand, there is no steel, so probably it's not so heavy. On the other hand, if it's lighter, it does also bring some problems with it if there is any touch. But honestly, exactly, I cannot answer it. I will. Hopefully not. We test, yes, but we hopefully will not that situation.
Thank you. Another question, Dennis?
Price? I would say it in that way. Added value, quality, and innovation, first of all, costs money. But at the end, you will earn it back. It's definitely more expensive, but you will make money out of it. So getting back to the two presentations of this morning from Christian and from Baldonaro, I'm sure that you will say, look, it's worthwhile to do it, as long as you get over 100 meters.
Anybody else? Question? Over.
Sorry?
Does it have more stretch when you lift it away versus steel?
Not a lot. Not a lot. I mean, it's up to a few meters, let's say, but it's depending always on the hook height, let's say. So if you have the standard hook height of, let's say, 40, 50 meter European standard hook height, you will almost not realize it. Obviously, if you go higher, there is a little bit more, but at the end, it's not bending. So it's into it. Until now, we are at 22 millimeters. So that's why I'm saying we are only at around about 300 meter ton cranes, because our bigger cranes have a larger rope. And as on today, we can only use it as a 2-fall rope, so not as a 1-fall rope.
Another question at the back?
6-month jobs, and the video showed 2 layers. Have you tested multiple layers beyond 2? 2 layers of rope?
Sorry?
Rope layers on the drum, have you tested beyond? The video showed 2 layers, and your 6-month jobs would indicate 2 layers as well.
We went into by far more layers, and we can also say the forces on the layers with the fiber rope are by far less than on the steel fiber rope, than on the steel rope.
So less crushing?
Sorry?
Less crushing forces and wearing
Yes,
forces?
definitely.
Thank you.
Yeah.
Any more questions? Oh, another question.
The rope itself, let's say, how much longer it lasts.
The sheaves.
It's not so much different, let's say, to the steel rope from that point of view. Yeah.
Okay. Well, thank you very much, Marco.
Thank you.